The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. And the topic of today's session is Model-Based Test Automation for Safety Critical Control. Our guest speaker today is Yogananda Jeppu. He is the Senior Systems Specialist, Moog India Technology Center. Yogananda Jeppu has over 26 years of experience in developing and test control systems in aerospace vehicles. He is a graduate in Electronics and Communication Engineering and a postgraduate in Missile Guidance and Control. His doctoral thesis is on certifying safety critical control systems using design of experiments and model-based testing. He has a US patent and many publications in conferences and journals. He has worked with the Defense R&D organization before joining Moog. As a systems specialist, he is responsible for innovation, R&D, training, and flight control system design, development, and testing in the organization. So, without further delay, I introduce you all to our guest speaker. Over to you, Mr. Jeppu.
Thank you. I appreciate this opportunity to share my knowledge with my friends. And today what I'm going to do is I'm going to speak about model-based test automation for safety critical control. Now, this is a very favorite topic of mine, and I have been working on this field for the last 26 years. And what I will do today is I will walk you through what is safety critical, what is control systems, what is model-based testing, what are the different accidents that have happened, and why is it so important, why is this field so important, what is automation in this, what is coverage metrics in this, and what you can do working for a company but enhance your knowledge in this field. So I'll be covering a little bit of all of these and try to give you an overview in the 45 minutes or 50 minutes I'm going to talk to you. I have seen the list of people who have registered for this, and it is a mixed crowd of youngsters and people with experience, people in the automotive domain or the flight controls domain, but a lot of freshers are also there. So I will try to keep it very general, and perhaps you could ask me for any specific details during the question and answer, or you could perhaps ask TechGig for a very specific sessions like this on a very specialized topic, and I could cover that later. We have covered this part. This is my introduction, and so I'll skip this. The two major drivers for me to work in this field are the accidents that happen. So what you see there is some of the accidents that have happened because of software failures. And then there is, the failure is not an option. For us who work in the safety critical field, especially in aerospace or in flight mechanics, I cannot afford a failure. So failure is not an option for me. So these are the two drivers for me to be in this particular field. So this is something I had put up on LinkedIn. It does not matter how frequently something succeeds. If a single failure is too costly to bear, one single failure, if it kills some 400 people in a flight controls application, it doesn't matter if I have succeeded for millions of flights. So this is what drives us to be very, meticulous in our endeavor to make things perfect. So what we are going to look out is a feel for a safety critical software, how we test it, a glimpse of the accidents, and what the standards talk about this. and I look at different test approaches. Then I will end with some best practices, basically my experiences in testing the safety critical system. I have been putting tips like this with a mark. So these are my personal experiences, my views of things, and basically coming from my 26 years of experience. So I hope that it's going to be useful to you. So starting, I'm going to give you the software in the industry today. So what you see before you is a picture of the software number of lines of code or the object instructions and the number of systems. So if you see here, a low-end mobile has the least number of code there, but very large number, 10 power 9 systems in the whole world. Whereas if you see the spacecraft, you have very few spacecrafts flying, but again the complexity and the lines of code is very high. But this is the complete domain in which software is available today. So what is safety in this? Safety is the freedom from those conditions that can cause death or injury. And a safety critical system or an application is an application where human safety is dependent upon the correct operations. So some of the examples that you're going to see is the railway signaling, the medical devices, the aircraft control systems, and even in the automotive domain. So what you're seeing is a railway signaling system, just two people sitting there and controlling the complete railways. So this is driven by software, and it is a safety critical thing. So the computer is doing and trying to manage the tracks, and accidents have happened in this. This is something which is there inside the heart. So it is working, instead of the heart you have a small artificial pump which has a software driving it. So this is the medical field. Then you have the programmable ECUs. So your family is traveling in a car, completely dependent upon the software that is running the show. And then finally you have the fly-by-wire control systems, where again it could be somewhere very close to you who is flying in these things, and the software is driving this. The software makes it fly for 16 to 20 hours. You go from India to US, the whole journey is done by these fly-by-wire control systems. And accidents still happen. So I'm going to show you some of the examples of the very recent accidents that are there. This is a very profound statement by Barry, and he says that the situation becoming worse will continue till a major software-induced system catastrophe, similar to the impact as a World Trade Center, collapse in 9/11. And when is it going to happen? It's going to happen somewhere between now and 2025. So this is a very profound statement, and something to be scared about. This is not a very good thing about the future. And you can see the trend now itself. You can see these accidents that have led to very large loss of money, 1.23 billion US dollars, because the filter coefficient was a factor of 10 wrong. Something we could have easily tested and perhaps found it out. In the medicine field, people were given dosages of the order of 105% more than the normal dosage, and people who went to get cured, they got killed instead. And this is not new. It has again repeated, where again a 8 times higher dosage was given, and people died because of that. And then the favorite thing for me, the aircraft field, where crashes have happened because of software failure. And all these things are pretty new. And as a hindsight, when we look at all these accidents, if we had done some extensive testing, perhaps we could have avoided this process. So we require all our wits and ingenuity to make a safety critical system work. outthinking nature is an overwhelming task. So this is what drives the safety critical business today. So what do we have for this? We have standards. We require standards to develop a safety critical product. And what are the different standards available? You have got standards in all the domains. So you have medical field with the 62304, you have the automotive domain with the 26262, you have the railways with the 50128, and the avionics with the DO178C. So you have all the standards in place. So we have done a good job there. The DO178C standard, that is because I'm coming from a aerospace background. So this is our daily, Bible which we read every day, sort of. And this standard tells you that there are 5 basic levels of criticality, and how we have to test them based on the criticality. And recently, the new standard DO178C has a model-based supplement which talks about how do you do a testing, how do you develop a system if you have requirements given as models. So this standard has realized that going forward, model-based is the way to do things. To start any activity, we require to have a safety analysis. So this picture basically tells you how the different standards are related. So you start with the safety of a system, and then you have the other standard correlating. So this is basically for an aerospace domain. So initially, we start everything with a system level safety assessment. So remember that there is a big difference between safety and reliability. A highly reliable boiler which can withstand 2 times the pressure may explode with twice the force in an unsafe condition. So you have to remember this specific aspect. Safety is different, reliability is entirely different. The software will perform very well as it has been designed and tested for this. It will very faithfully carry out the function defined by the requirement. So we have to ensure that the requirement is safe under all conditions. So requirement is what drives your safety. These are basically the criticality levels in the DO178C. So you have the software criticality, catastrophic, these are talking about the accidents. And what should be the probability of failure? So 10 power minus 9 failures in 1 hour of operation is a software with catastrophic criticality. So this is what should happen. And 10 power minus 9 is a very small number in 1 hour of your flight or 1 hour of operation. And that is designated as a level A for a DO178C. And 178C lays down certain objectives. So it says that you have to fulfill these objectives to come up with a better system. So one of the objectives could be low-level requirements have to comply with high-level requirements. So things like that. So there are a set of objectives which are there categorized over different product life cycle. So in the life cycle phases. So you have planning, you have development, verification. So if you see here, planning and development has 7 each, whereas verification has 43 for a level A in a DO178C. And there is something called as independence there. So you have, if you see for a level A, 25 objectives have to be looked at with independence. So what does you mean? What do you mean by independence? Independence means that if I am doing the piece of code, if I am writing the requirement or I am writing a piece of code, then there should be somebody else who has to review it and ensure that what I have done is correct. So that is independence. The essence of DO178C is that every line of compiled code is directly traceable to a requirement and a test routine. So it should be traceable both to a requirement and a test routine, and there is no extraneous, or outside code, and the proof of this should be generated on the actual system that flies. So that is very important. Where you test it on the actual system that flies. That was about the DO178C requirement for the standard for the aerospace. In the automotive domain, you have the ISO 26262. And beautiful comparison is given in this particular paper. It's available in Google. If you search for it, you'll get that. A very well written paper which says can cars fly. Okay, and actually they can. So there is a car which can actually fly. It is half aeroplane and half car. But the standard is pretty much applicable. Now, in DO178C, you saw a lot of levels. So even in 26262 for the automotive, you have different levels, which are, I think, classified in a better fashion than 178C, because you have classes for severity of an issue, you have classes of probability, and then controllability. This controllability is not there in the 178C. And based on these things, you define your levels. So you define the SL levels based on the probability of occurrence, the severity of the accident, and so that is how the level D is the most catastrophic, which is level A in 178C is level D here. And if you see 26262 recommends different ways of testing, which is not available in the 178C. 178C doesn't say how you go about testing it, whereas 262 says how to test it. And there is a back-to-back test where the responses of a test object are compared with the simulation model. So it is basically talking about a model-based test here. When you do a comparison between, you will see that there are a lot of commonalities. One thing is the modified and decision coverage. This is basically talking about a code coverage where both the standards talk about the same thing. And it is mandatory for level A, and it is also mandatory for the 26262. The other standards are the 61508 for the industry. Again, you have the same gradations here. What is acceptable, what is the probability of failure. So everything is on the same lines. And you again have the 10 power minus 9, 10 power minus 6 numbers, which are there in DO178C. So the numbers are also pretty much the same. Similar, and again, in this case, there are only 3 classes of criticality, which go from A to C. C has the highest criticality. And again, you have different levels based for the medical also. So coming to the whole thing, what I summarize this is that there are many religions and doctrines in the world today, and they all talk about the same thing, right? Be, go, do this and all that. Similarly, all our safety standards, they are talking about the safety levels and what you better do about it. So this is all the standards talk about. So it doesn't matter which standard you are referring to, it is one and the same. And the source of all development is requirement. Treat it like a Bible or whatever your religion is. Treat it with the document or a book for your religion and preach it to everybody who is involved in the project. So this is very, very important. What we have seen is most of the time errors happen because of requirements rather than anything else. So I'll just cover a bit of mistakes that we have made. These are what you can see here is the recalls attributed to software failure, and the very recent data for the medical field. So you have a 18 to 20% recall because of software failures alone. How does the industry do today? So if you see here, if you have the space shuttle software, it has 0.1 fault density of 0.1 per kilo lines of code. The nuclear industry has 1.14 into 10 power minus 6 per hour as the failure rate. So what are we finally saying? We were making a system with 10 power minus 9, but what we have ended up today is 10 power minus 6 only. So we have a long way to go. And why is this happening? This is happening because the software, the way it fails, you have an error somewhere. So that is the software boundary. So there is something wrong in your code that you have written. And unless you exercise that, it remains there. But the time you exercise it, it results in a fault at the software boundary. This fault may or may not result in a failure at a system boundary. And if at the aircraft level boundary, so that error may remain dormant like a volcano for a very long duration, but the resulting eruption can be catastrophic. So I have experienced this. We have had errors in our flight programs, and easily we could have lost an aircraft if this error was not trapped during the testing. So we should understand that the behavior of the control system or behavior of the algorithm, which is very important. Don't treat it like a code in a we have a tendency to make the same mistakes again and again. So this I have seen it pretty often, and the verification team's observation, that there is an error, then the designer will say that, okay, you are doing a too rigorous a testing. That is not the way it will behave in testing. So don't believe all these things. This is not true. If you have found an error, be sure that when the system behaves in the field, it is going to come up with this error. Another thing is that we always make mistakes in the initialization, variable initializations. This error, I was in a call just last week, and I was talking to this friend that we have found that initialization error again in the very recent build of software, and this is in a flying aircraft. So this we always keep making the same mistake, and especially in the initialization. So this requires a set of tests so that you just test the start, and each time you have to do a system restart. So this is very important to test the initialization. Testing safety critical control system requires that the tester has to understand a lot of things. He should understand the control system, the algorithm, the different standards, the test methodologies, what is a model-based testing, what is the block coverage metric, what is a code coverage metric. He should know more than a developer. I always get this feedback saying that, sir, I want to be a developer, I don't want to be a tester. But a tester should know more than what the developer knows. So it is very important that the tester is much, much better than a developer. So this is what I always feel. And coming from a testing background and going back and again doing a development, I get to see, I think the way we do development is much better because we know that, the tester feels these needs. So any day a tester is far better than a developer. Now what is model-based testing? So model-based testing is a requirement testing where the requirement is given as a model. So a model is something that you can, it's not just a picture alone, but it is an executable. You can run it, give it some inputs, it can give you the outputs, and then you inject the same inputs into your code, which is running on the onboard computer, and then you match these two, and if both of them match, then you say that, okay, your code is the same as the model. The code behavior is the same as the model. So this is very important. And not the model comparison. You have to say that the complete the test case has given you 100% model coverage, and it has given you 100% code coverage. And how well it matches, you will have to indicate beforehand. You don't do it after doing the test. You see that, okay, error is 10. Is it acceptable? You say, okay, we will accept it. It's not like that. Before you do the test, you have to say that, okay, if it passes with 1% bound, I'm good. And I'm getting a 10% bound, so there's something wrong with my software. This is basically a schematic which talks about the comparison of the model and the code. I'll just walk you through a small example which has happened in one of our missile system, and we lost the missile because of this. So what I have is a limiter there, and there is a discrete filter, and again a limiter or a saturation. And the limiter input is limited between plus or minus 20, and output is limited only to plus 9.5. And we designed a set of static tests, to test it out. So the input and the model both were excited by zeros. 0 is a very good input to test, and output was 0. No issues about that. So output was matching between the model and the code perfectly. So there was no issues in this. Now, is it sufficient for a safety critical system to be tested in this manner? So we said, okay, let us do some dynamic tests also. So we ran a sinusoidal waveform with 10 Hertz. We ran through this, and it was matching. The code and model was matching. We said, okay, it's something wrong. Something is not right. So let us run a small 0.1 Hertz signal waveform, do it very slowly this time, and then we realized that the output of the code and the model was not matching. And we had a small error. So if you see this plot, this error is very small, minus 0.6 or something, a very small error which we could say is insignificant. But this was actually a major error where the same variable was reused, and because of this, the missile, shattered. It just broke apart. Nobody got hurt, but this is what happened. So what is important is that you have to have test cases that test the systems. So the test case that you do should be testing your system rather than just the code. So the test case design is very important here. So you should spend a lot of time, I would say some time, better spend a lot of time thinking through that, how you are going to test the system, not just the software alone. Okay. I started on model-based testing with a Fortran model for the LCA program. So we didn't have Simulink and all that. There is nothing like a model there. It was another piece of code. But today we have a Simulink model for the resegmental blocks, which was used to develop the Boeing control law, and we did the model-based test. This is a very recent thing, maybe about 6 months back. A frame-by-frame comparison with a model is a very powerful way of testing dynamic behavior of the system. So the fact that the model and the system, model is a system requirement, it is a direct requirement-based testing. That is the way you should be testing any system. So if you do a frame by frame, every frame I do a comparison and say my model and this matches, I'm very good. So in the LCA context, there was a Fortran code which was used by the system designers themselves. So that was our benchmark model. Even though it is a piece of code, but it's a different language written by the designer themselves. And pilots have flown this, so we had a lot of faith in this code. And we ensured that the LCA aircraft, when it flew, the ADA code matched this Fortran code very closely. The new standard has the DO 331, the model-based supplement. It has brought out certain rules and regulations on the models. It says that you should have a good modeling guidelines. So if you are going to practice model-based testing, make sure that you have a very good modeling guideline so that you make sure your models are good. you have to ensure that all your system, the simple blocks, the subsystem level or the smallest blocks, they are tested thoroughly. So make sure that you test them very thoroughly, and for our programs, for the Boeing program, we used Excel, spreadsheets with the. I will not use our testing. So we do a lot of automated testing. So automated testing could be just a collection of manual test cases. We had a team of engineers who have built about 1,000 odd manual tests, and we can run it in a batch mode. That is test automation. At least the execution is automatically done, even though the development was manual. And well defined before, so that you know that automatically it can tell you whether your test case has passed or failed. So normally what we do is we run our test cases on a simulator, ensure that our test cases are very good, and then we run it on our board. And a lot of tools are developed proprietary to a company. So most of the companies, they develop their own tools, and they used it in their automation. And if you are developing your own tools, then you will have to qualify it for a certification. A lot of generating automated test cases, and this does save a lot of effort instead of doing everything manually. But if it is generated automatically, then there should be somebody to review that and say that, okay, your test case is good. And a lot of effort and money is spent on qualifying these tools, because if you are using a tool, you cannot blindly use it. So a lot of money and effort is spent in qualifying these automated test case generators. So we have done that in Moog also for our own programs. One of the methods that you can use is to generate random test cases. I mean, this is the simplest way of doing things. Just generate some random waveform, inject it into your requirements, inject the same inputs into your code, and look at the coverage metrics. And if both are matching, then you have done a fantastic test. So random test cases are the easiest way of optimizing test cases. We have done it for the Indian SARS program. I was working with Honeywell then, and the whole thing was automated, and we could generate a set of test cases, an optimized set of test cases, which would cover the complete SARS mode transition at a system level. So it is possible to generate test cases just by giving random sine waveforms. If you are working on control systems, then just generating a random noise doesn't help. Okay, I cannot have random noise injected into a filter. It will say that it is noise and remove it. So what we normally do is we generate a sine wave with a random frequency, a random amplitude, and a random bias curve, and these waveforms are injected into the system. So this works very well for us, and we have found enough issues, and we still find issues just by following this method. Another thing that we did was, okay, how many times and what should be my frequency, what should be my amplitude? So what we did for the LCA program was we analyzed the LCA flight profile, the way the pilot flies it. We looked at 10 or 15 of the test sorties, and we decided that, okay, most of the time it's a very low frequency zone, and higher frequencies about 10% of the time you have a higher frequency zone. So 1 to 3 hertz is about 90%. So we said, okay, we will just generate test cases with a lower frequency most of the time, and we'll have additional test cases with higher frequencies. So things like that. So you have a if you have a lot of data, you can think of a simple techniques to come up with some realistic numbers. Let me talk about coverage metrics. So when I say that I generate a random test, it's just not I generate waveforms and inject it. I have to look at coverage. So one thing is I have to look at code coverage. So there are ready-made tools available which instrument the code and give you a coverage metric for that. But
you require to do your model coverage also, the requirements coverage also. So what we have done is we have come up with our own metrics for our control system. So you may have to come up with certain metrics which is very specific to your application and say that when do I say whether I have covered my system requirement or not. So a little bit of skillful programming on your part can come up with very simple tools, very tailor-made for your specific requirement, and it is worthwhile spending some time at the beginning of the project to have these tool sets ready, and it will go a very long way. So this is what we have seen, and 1 week of effort, and we have generated tools which has been used throughout. So the test cases should cover the system requirement. I keep repeating this, that you should not only look at code coverage but at system coverage also. The system requirement should be completely covered. Code and model coverage are not, they are good metrics, but they don't indicate a functional coverage. So always look for some functional coverage and come up with your metrics which says that there is a functional coverage. I don't know how many of you use orthogonal arrays for testing. This is a very nice concept of reducing test cases. So using orthogonal arrays, we have generated test cases for the LCA program, for the SARAS program earlier. We have used it for the Boeing programs also, where I can generate very optimized test cases by running these orthogonal arrays. So there is a program, a freeware software called orthogonal. So you could use that is available. Google on all pairs. I think I have given the web address also. In case it is not there, you can Google for all pairs and you will get this tool. There is the ACTS software, ACTS software from NIST USA, and this is again a software which can help you make these orthogonal arrays or covering arrays. Excellent tool which can help you do a test case design. I think it is worthwhile going there, downloading this tool and using it in your test cases and procedures. So what are basically these orthogonal arrays? If you look at this array behind, what it is showing you is there are 7 columns there and 8 runs. And if you take any 2 columns, say 1 and 2 if you take, all combinations of 1 and 2 have been tested, 1, 1, 1, 2, 2, 1, 2, 2. So take any 2 columns, all combinations of 1 and 2 have been tested. So in an orthogonal terminology, we will say that this is a 2-level orthogonal array because the levels are 1 and 2, and it has 7 inputs, so you can look at 7 factors, and it has 8 experiments, so it is basically known as an L8 array. Now, where do I get these orthogonal arrays? They are again available. Just Google for orthogonal arrays and you will get a list of hundreds of orthogonal arrays which can be used by you. The other technique that we have used is on error seeding. So this has helped us during our LCA control log, where we injected deliberate errors into a system and we called it a delta model. And we had a model, we had a delta model. Delta model had a single error injected into it. And we ran test cases to find that error. We done something very similar for our Boeing test cases also, where we have a Simulink model, and in the model we inject one error, we generate a test case. If the test case can find this error, we say that okay, this test case is very good because it can find my seeded error. So similarly we do this, but it's a laborious process. You have to do it for all the blocks in your model, but it is one way of generating test cases, an excellent way of generating test cases, where you know for sure that your test case is good to bring out your error. I'll cover a bit about what MOOC does in this field, and some of the tools that we have done. I can't give you the details of that, but some of them are openly available. One of the things that we have done is we have come up with our own requirements coverage. So there are papers written on this already available in the open domain. So you can look at that. And this basically tells you whether I have covered a specific metric or not. So like if you have a saturation block. So in a saturation block, what are the different metrics? I should ensure that the upper limit of the saturation is hit, a lower limit of the saturation is hit, and I should ensure that my input is between the two limits also, where it is passed as it is. So things like that. So you will have 3 metrics, and I should have a coverage for all the 3 metrics to say that my test case is good. A very basic concept which has been extended to more than 50 blocks for our Boeing program. So this has come out as a tool which has been qualified, and we have got excellent results using this. We have used simulated annealing and genetic algorithms to generate test cases. We have done some experiments using our tool which gives you the coverage. So we have generated test cases automatically which gives you 100% coverage, and optimized it. So for a very specific block, I may have just 5 or 6 test cases which gives me 100% coverage. So if you Google with my name, JPPU in MathWorks, you can find these blocks. You can find 2 benchmark problems with the test cases on the MathWorks website. So you could download it and use it. We have used design of experiments to generate test cases. So basically going with the orthogonal array, we have extended it so that automatically design of experiments framework has been used, which is actually used in experimentation in microbiology also, or to optimize the making of chips and all this. We have used the same techniques for optimization of test cases. I'll just cover some of the best practices, and I will close for the day. Automate the complete test process as much as possible. That is the first thing that you should do. This will help you quite a lot. Analyze every case that you make. The first time you do this, analyze every test case. So most of the time what has happened is the test case is wrong rather than the code or the requirement. We would have made a mistake first time we are doing things. So look at it very carefully the very first time you do it. Once it is done, you're confident, you're working, everything is working fine. You can very easily use it for the regression tests and all that. But very first time you do it, better be very careful. Have a configuration management in place. Very, very important to store all your test cases. SPN is there, Jira is there. You can use these open source tools to store your test cases. Always develop a front end. Better to have a GUI sort of thing so that it can ease your test process. Eyeball the requirements and the model. So normally when the model comes and the requirement comes as a code, preserve your independence, but please do eyeball these two. You will find a lot of issues. Before you do the testing itself, you would have found issues. Errors like bugs are always found in the same place. So this is what I keep saying. And so always you will find cockroaches behind your sink. So the errors also are in the same nature. Always you will have initialization errors. You will have errors in integrators. You will have errors in gains. You will have errors in lookup tables. We know it. Last 26 years we have been seeing errors in the same place again and again. So look for the errors immediately. And if you are working for a US company, so you will be under a lot of pressure, finish the testing within 2 days. Look for these things first and find these errors, throw it back at them. Then, they said, okay, we have to correct all this. So while they are correcting all this, do your other testing. So play an intelligent game because you're coming at the very end of your project. So play intelligently and do a good job and find these errors fast because you know where to look for. Have a systems guy handy nearby, talk to him and understand the system more than the software. Tap out a lot of global variables if possible. Tap out the internals and compare. This will give you an insight into the working of your code. Use random testing as much as possible. We are incapable of thinking of all combinations because we are humans. We just cannot think what can happen, what can go wrong. So use random testing. It doesn't matter if it is ridiculous, but do it. We do testing with the aircraft on ground with the tires up and trying to fly up. Do all sorts of nonsense, but at the end of the day, it can give you some good insight into the working. Always remember that as a tester, you are the last line of defense, especially for a safety critical system. And always remember that you have to break the system. Okay, It actually gives you a perverse pleasure, and people call you an eccentric, but you do save lives. So always remember that you are always the last line of defense between your system and your family using that system. Okay, so always remember that. Software testing presents a lot of opportunities, and there is a lot of scope for improvement. So you can still do a lot of things there. This field can be explored for higher studies also. If you are working in this field and you want to do a higher study, try and do higher studies in this specific field so that you can understand. Experiment with software like the chemists. Mix two different things, look at different ingredients, put them together, and see what happens. Something new will come up. Use those things. Okay. And last line of the slide. Let us not wait for the software catastrophe of 2025. So let us do a good job now. You guys can contact me anytime. Okay, I'm on LinkedIn. My Gmail ID is here. And thank you for listening to me.
Thanks for the insightful presentation, Mr. Jappu. Let's quickly take up few of the questions, and I request you to read out the questions and their answers so that all users may listen to the insights.
I have a question here which says, do we need to consider the ARP 4754 objective while doing a model-based test? You may not have to consider it. It is something what the system level guys do because it is a safety standard, and so you do that beforehand. And in case you find some issues during the testing, you may have to go back to the safety standard. So you need not do it during testing. You don't have to refer to that. If you are in an aerospace domain, I understand you would be in an aerospace domain. Look at DO178C and DO331. You are good enough with that. I have one more question. When do you consider 178C and this for VNV in avionics? So I think I have covered this. One is during the design of the complete system, whereas 178C is basically during the software design. And once you have apportioned your system requirements into your software and hardware, and you come down to the software alone requirement, then you look at the 178C, and then you proceed with the complete task of the 178C process. Another question is it complete white box testing? I understand this. You're talking about the model-based as such. So if you are looking at it internally, you are doing what we call as a low-level test, then it is a white box testing. But you could have that same model, stitched together at a higher level. So for the Boeing, we had individual blocks which we tested at a low level as a white box. But we had components of all these blocks put together into a bigger picture, and we did a end-to-end black box testing using this, and then with everything together, we did a system level test using the same models. We did a system level test. Any good tool for verification of code coverage? There are a lot of tools available. So we are using RTRT here. We have used LDRA. So two good tools that give you code coverage. And I think there are certain freeware tools also available which give you code coverage, but they may not give you MCDC. I think Parasoft is another company which has its own tools. So I think there are enough tools available in the market today. Only thing, when you use these tools, make sure that you can qualify it. So most of the tool vendors today are giving you qualification packages also so that you can do a faster job of it. Which tool you prefer for model-based, MATLAB model-based test? We have not used any ready-made tools. I have used Reactis for automated test case generation. You have the tools used given by the MathWorks themselves as part of MATLAB, which can generate a lot of test cases using formal methods or just random tests. So there are a lot of tools available. We prefer our own tool sets. We have not used it. We have prepared our own tool sets which give you the coverage. So I mean that is the way we have done it. It doesn't matter because automotive domain has got very good results with reactors, with TPT, and different test tools that are available today. What is combinatorial testing? It's basically testing using an orthogonal array and a coverage metric. So orthogonal array, if you see, there was a symmetry about it. You know, you had equal number of 1, 1, 1, 2 values. In a covering array, I'm not looking at a symmetry. I just want to ensure that 1, 1, 1, 2, if it is covered, and 2, 1, 2, 2 is covered, then I'm happy with that. I don't have to worry to have multiple. So the first instant when I get a sufficient coverage of all these combinations, then I can do this. So that is basically used the combinatorial testing that uses a covering array. So the ACTS tool basically gives you the combinatorial testing feature. One good thing about ACTS is you can have increased interactions between the different columns. So I can specify that what is the kind of interaction. So instead of using 2, that is 1, 1 between 2 columns, I can say that I want 1, 1, 1, 1, 1, 2 like that. So all 3 columns together, or I can have 4 columns together. So I can specify that interaction in my ACTS tool. So that is possible to use. I am done with the questions. Anybody else has any questions? Please do.
I request the audience to post their queries if they have any. We have just received a query from Anuparna Mehta. Did you get it, Mr. Jeppu?
Right. Sun and Jira. Can you? What is Sun and Jira? I mean, Jira is subversion SVN. Okay. SVN and Jira, we use it for our configuration management. So SVN and Jira is basically an open source tool that is available for configuration management, and you can download it and put it on your PC if it is on the network. So you can make a repository, and everybody can use the same thing, same repository if you are linked up. On Move side, we have come up with our own configuration management tool based on SVN and Jira. So we have added our own new features, and which follows the Move process and the Move guidelines. So we have tailor-made the SVN and Jira to suit our purpose. But you can straight away use SVN and Jira the way you want it. You can report your own problems, and you can store the data in SVN. And it keeps tracks of different versions and all that. If you are using MATLAB and Simulink, it has a seamless interface with SVN and Jira, the new versions, so that can help you quite a lot. Any other questions?
Yes, we don't have any more queries right now. Do you want us to wait for some time for some queries to pour in?
We have about 5 minutes, I guess. I can wait another few minutes in case no questions. Please do. You have my email ID, and you could always get in touch with me, and I can link up on LinkedIn. In case you want some very specific trainings that are to be done, I am game for that, and we can look at anything detailed. If you want to look at OA and combinatorial testing, I have enough examples for that, so we could have a full session on OA sessions, OA and combinatorial testing.
I think we are not getting any more queries. The audience are pretty much set for the presentation after the
Right.
wonderful presentation. So do you want to sum up this presentation for the day?
I think what I have covered today is just given you a glimpse of what we do in a model-based scenario for a safety-critical control system, and I have tried to cover the different aspects of it, the standards and the the test methods, the random testing, the OA testing, and the optimizations, and what is the coverage. And I've tried to give you best practices that have cleaned over the years. I hope it is useful to you. And do come back, do stay in touch, ask me questions anytime later also, and have a good day.
I'm really thankful to our guest speaker, Mr. Jeppu, for conducting this wonderful webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all for joining us today. Thank you, Mr. Jeppu, for taking time out for this webinar.
Thank you. Thank you so much. It was very nice interactive.
Thank you, sir. Have a great evening ahead.